Hi again. In this video, we're going to do another example of a sampling distribution using the theoretical model. So let's see, and I've got my page with the models and conditions right here to refer to it just in case. And let's see what this question is about. So it says the composition of pennies was changed in 1983, partly due to the rising cost of copper. Do you remember earlier in the class we had a bimodal histogram that showed pennies? And so I learned more specific information for this question, that there was actually changed, the material was changed in 1983, and it was because copper was getting more expensive, so they replaced, I don't know, all of it or a lot of it with zinc. So they became lighter. So here's what we know. The weights of pennies, okay, so we're talking about weights. The weights of pennies minted beginning in 1983 follow a normal distribution with a mean of 2.5 grams and a standard deviation of 0.03 grams. Okay, so I'm kind of underlining as I go, but keep in mind you might need to read a question a few times to get all the information out of it. I've read these many times and sometimes done the video a few times as well. The earlier pennies made between 1865 and 1982 weigh approximately 3.11 grams. Okay, this looks like it's probably extra information, but we'll see if we need it as we go along. But it does look like the old ones were heavier and the by over half a gram, and the new ones are lighter. Okay, so let's see what we're doing here. If a single penny is randomly selected, define, draw, and label, and you see that a lot, the distribution for the weight. What's the probability that a single penny weight is less than 2.4 grams? Okay, so notice this is for an individual. So we're not getting to the sampling distribution yet. And you'll see this with means a lot, as we'll look at the graph of individuals, the population of individuals. And we have weights of pennies. This is a numeric variable, right? Weight. That's why we have a mean and a standard deviation, not a P and an N. Okay, so we do have a mu and a sigma, right? Our mean and standard deviation. And we don't have an N yet. N is 1. We're just looking at individual pennies. Okay, so this is actually like in the previous section when you did the normal model. This is a single normally distributed population. So we have X is distributed as normal with a mean of 2.5 and a standard deviation of 0.03. Okay, that's why single is underlined here, because it's just one penny. Okay, so we're not dealing with X bar yet. Dealing with X. Define, so that's the define part. Draw and label. So you could go to Staplet right now to draw it, or you can draw it freehand. I'm going to make mine pretty wide because we are gonna do a sampling distribution, and I want to use the same scale. So I'm going to leave myself space underneath to label it. Learn from my last mistake, and then make a distribution that's pretty wide like that. Okay, so remember when we label these things, we put the mean in the middle. My normal curve, so the mean goes in the middle, then I go to thirds, 1, 2, 3, 1, 2, 3 on each side. And 0.03, so at this point I think I am going to go to Staplet because I can have it do the calculation for me. So I'm going to put in my new mean of 2.5, and this is grams, right? And 0.03, plot distribution. Okay, so I can read my numbers off of here. So I'm just going to read them off. 2.53 going above the mean, 2.56, 2.59, and then back to 2.5 in the middle, going down, 2.47, 2.44, and 2.41. Okay, and then remember you can do a screenshot of this if you prefer, if you're typing, or you can draw it by hand, whichever way you're doing it. And then I'm going to write penny weights. In grams. Okay, so if we were to see a histogram of this, these would be individual pennies, right? And that's why I'm using X and not X bar. Okay, there is a probability question here as well. So we did the define, draw, and label. So we did define, draw, and label. Now we need to find the probability. And it's going to involve X. What's the probability that a single penny is less than, so X is less than 2.4 grams. Now we have to go over to Staplet at this point, and we are going to the left of a value, to the left of 2.4. Okay, that's pretty small. That's negative 3.33 is the z-score, so that's 3 1/3 standard deviations below the mean, so it's past 3, and our area or probability is 0.0004. Very small, 0.0004. Okay, and I should put that on my graph, and that would probably make sense, right? Less than 2.4, oh, I can see 2.4 is past 3 standard deviations. So if I had graphed this first, I would see this is just this tiny little area right there. Okay, so that's what you're used to doing already from the normal distribution. That's good practice though. Now I'm guessing we're going to get to the sampling distribution part. If you have 3 pennies in your pocket, discuss each of the conditions required to use a sampling distribution. Okay, so now we've got 3, and we've got a sampling distribution, and it also says the word average. So these are all key words and phrases that tells me we're using sampling distribution. So now we're talking about X bar. Average weight of 3 pennies. So we have n equals 3. Okay, so we can do the conditions. So I have my conditions page out here. 1, 2, 3, and then for a mean, this time we have a mean, so we're going to do sample size. Okay, so let's start with 1, 2, 3. 1 is independence. The pennies should be independent from each other. In terms of weight. Okay, they also would all have to be 1983 and later, right? If we're comparing, if we've got pennies from earlier and later, that's not going to work. So also all, I'll say greater than 1983. Okay, so do you think pennies, if you had 3 pennies in your pocket, do you think they would be independent from each other? I'm guessing, pennies get mixed around a lot. They get spent here, and you get them as change here, and they sit in those little tiny trays when someone needs an extra penny. So I'm thinking the pennies are pretty much, randomly distributed around. So I'm thinking this would probably be met. I'm going to say pennies are well mixed up, as in circulation. Okay, so they probably would be you wouldn't have, be pretty rare to have like 3 pennies from the same minting batch in your pocket, right? I think that would be pretty rare. Okay, so that's independence, and that's randomization is tied into independence as well. So randomization, we need a random sample. So do you think these 3 pennies would be a random sample? I think that probably would. So it must be a random sample. Three pennies in your pocket. It is probably random. However, if you wanted to make sure, you could go to your whole change jar and, randomly mix them all around, randomly select a random sample, making sure they're all 1983 or greater. Otherwise, you're going to have a lot heavier one stuck in there. Okay, so great. 1, 2. Our third one, remember, I'm looking at my notes. Look at your notes too, is the large population. So our population must be at least 10 times the size of our sample. So large population. The population of all pennies, at least since 1983, must be 10 times the sample size. 10 times 3, we have a very small sample. 10 times 3 is 30, so yes, that checks out. Definitely more than 30 pennies in circulation. Okay, for our last one, I'm going to squeeze it in here, is our sample size condition. Okay, and I'm going to bring the notes over for this one because there are 2 conditions for this, or 2 possibilities for this one. So remember, here's our first 3 that we did: independence, randomization, and large population. And then the sample size for a mean, since we have a quantitative variable, the weight of pennies, it depends on what your population is. So if they tell us the population is normally distributed, even small sample sizes will have a normal shape. Okay, and that is the case we have here. They told us the population of pennies is normally distributed. That's why we can get away with doing this with only 3. If the population is not normally distributed, though, then we have to sample at least 30 or more. Okay, so I'm going to write this first one. Our population is normal, so any sample size is fine. Okay. Sample size, our population, or I could say the population of pennies, is normal. And if you want to just refresh, they did tell us that right here. The pennies follow a normal distribution. So they have to tell us that. Otherwise, they might say something is skewed to the right or skewed to the left. Okay, or unknown, or something like that. Our population is normal. So any sample size is fine. I'm going to say any sample size works. Okay, great. So it just takes practice to do these conditions. So when you do a few, you'll get good practice at it. Okay, now define, draw, and label. So this is very similar to part A, but now instead of an individual penny, we're talking about the average weight of 3 pennies. And it does say to draw this relative to your drawing in part A. So what I'm going to do is make it down here, and we'll see what our standard deviation is. It should be less, right? So it should be a narrower graph. So I think that's a good visual to have. But let me define it over here on the left side. So now we're talking about X bar because it's a mean of 3 pennies. So if we've met all these conditions, we do follow a normal curve. Our mean is 2.5, which is the same. And then I'm going to use our formula right here for sample means. The mean, and then for our standard deviation, we take the original population standard deviation and divide by the square root of n. Okay, this is our theoretical formula. So actually I didn't write out the formula here, so I will do that. Sigma over square root of n. And I'll fill it in below. X bar is normal, this was mu. 2.5, and then our original standard deviation was 0.03 divided by the square root of 3. Okay, so let me calculate what that is. 0.03 divided by the square root of n, which is 3, is 0.0173. 0.0173. Okay, and our original one was 0.03. We can see it there as well as there. So that's definitely smaller. That's half to a third, right? Well, a little half or over. Okay, so let me go ahead and put it into Staplet to do the math for us. So this is great if you're doing a question like this and it has an individual and then a mean, probability for a mean. We can keep our mean the same, right? And then we just change this to our new smaller standard deviation, 0.0173. Voila, and we have it. And so now I can see mean is still the same, 2.5. It's going down to 2.44, and it's going up to roughly 2.55. Okay, so let me put this, I'm going to draw, I left myself a lot more space on this one. So I'm going to draw a line on my notes like this, and I want to, I can't quite get both of these on. I want to use the same scale just so we can look at them together to compare. So let me go back to the Staplet for a minute. I'm going to keep my 2.5 in the middle, and then I'm going to see where 2.44 and 2.55. Okay, so this is just a little bit rough, but you can see I'm using my scale up here, and I found this new average of 3 pennies goes down to about 2.44. That's 3 standard deviations, and it goes up to about 2.55. So by doing this, I'm just going to get a visual of how this one's narrower than the other one. And I'm going to fill in 1, 2, and 1, 2, and I'm going to draw from here to here my normal curve. So it's going to be a little taller and skinnier. Okay, just kind of make a sketch like that. Okay, and so now I can't quite get them both on the same page, but you can see that we can see them more relative to each other. Let me fill in these numbers here, and I'm just going to round these. For the if you're hand drawing, it's okay to round to 2 decimal places, or even in this case 1 decimal place. This is going to be 2.5. Well, I have to do more than 1 because these are all like 2.5. So I'll go 2.52 and 2.53. Can barely squeeze it in there because it's about, the standard deviation is about 1 to 2. Then going down 2.48 and 2.47. Okay, it's rounded a little bit, but that's okay. I had to squeeze them in there. Now, so that's define and draw. We need to label this, okay? So these are not penny weights anymore, right? This is the average of 3. So average weight of 3 pennies in grams. Okay, again, I've got the 3 because that defines this graph, because that tells us that what this standard deviation is. If I had 5, it'd be wider. 5 would be wider. 5 would be narrower. The bigger the sample size, the narrower it is. So 5 would be narrower, 10 would be narrower, 100 would be even narrower. So you can see this one isn't that much narrower than the original because it's only 3 pennies. Okay, almost there. One last part. Now is when we get to find a probability. What's the probability that the mean weight of 3 pennies is less than 2.4 grams? So notice we found a probability of 2.4 above, but now we're talking about X bar because it's saying what's the mean? And we've defined our X bar model right here. Okay, so probability that X bar is less than 2.4 grams. What do you think it's going to be? Because our distribution came in, it's narrower, right? So my 2.44 is right here. So my 2.4 is actually way out here. I don't know. Is it going to be 0? It's possible. It's hard to get much smaller than 0.0004, right? So here we've got our new standard deviation that we already put in, 0.0173. We're still going to the left of 2.4, so I just need to calculate area. Yeah, it is 0. And notice how they put approximately 0. That's a good practice because it's not, 0 means something's impossible, right? Is it impossible? Maybe, but it's very, very, very small. So, and you can see this is over 5 standard deviations from the mean. So yeah, that's very, very unlikely. And here you can see the model definition up here, which is great. So you're welcome to use that as well. And that's why they don't, I think that's why they don't put the X bar tilde, because in this case it's an X bar, but they don't know if we're doing X or X bar or P hat. So that's why they leave the variable off. That's my guess. Okay, so I'm going to put 0. It's okay to put equal 0, or you could put the approximately equal 0 as well. So sometimes you will get an answer of 0, so don't let that bother you if that comes up. If you want, you know, just verification is like looking at the graph and saying, yes, that z-score is negative 5.78. So this is way far away from the mean. Okay, great. So there's another sampling distribution problem, and we'll do one more in the next video.